So let me just go straight into what I built. Okay, it's very very important that I mention it because it's something that needs we all need to understand. You get it's not rocket science, and I see some people sharing their opinion, asking me some few questions on based on because Amos Spiking reposted it, and that thing is very very simple. It's just the mental model is you load the file. Initially, I was loading the file into memory, and then I'm reading it, and I'm doing a data conversion because the data set is very dirty. So we have some null, inconsistent data types, some rows were empty, some fields were not doesn't have anything. So because of those data inconsistencies, I need to do some data cleanup and filtering and conversion of dates. You get so loading the file into memory, creating a virtual table using data table to mirror what I have in my database, to mirror the structure of my database, and then doing date conversion and uploading data. So there is chain of memory intensive tasks going on already. As you can see here, I'm creating a mirror of my database virtual table which is holding some objects in data. I'm doing data conversion and the date passing, and then I'm uploading to DB. You see the chain. Everything here is memory intensive. So the trick here is not even the streaming that applied to this process. It is being able to look through my code and understand where I am performing memory intensive tasks, and those are the things that are actually slowing the process down. Because C# as a language is very strong enough to accommodate it, but the problem is that there are so many memory intensive operations going on in between this chain, and I needed to identify them and then abstract them. And immediately I did that, everything works faster. So the streaming was like an icing on the cake. It's proper structuring of your code, proper understanding of the each process of your code, how it affects the hardware and the entire process chain. You understand? So that was actually what happened. Now let's now break it down. The mental model is I decided to use a CSV file helper. Is a package in C# that helped me to stream the data, right? And also using C# file stream class. So it helps me to open the file in a streaming mode, and then the CSV reads that data row by row. So it picks up a row, does the data conversion on the fly. It doesn't put them in the memory because the CSV gives you an opportunity to create a class, more like the same thing I'm doing in my data table. So I create a map class that maps the data structure of my table. So it uses that data structure to do the data conversion. And again, I was also doing a data intensive work in my date passing. I was using switch statement to pass my date, which is very, very wrong. So but I changed it to work in a way that I just received the data, convert it to the actual data type that I need without having to run all those nonsense things I was doing before. You understand? So I moved that process. So as you can see, the Csvhelper has already done a lot of bunch of heavy lifting for me. So he's picking it row by row, doing the conversion. I'm pushing the data is now clean. He push it to the SQL. It does this thing just row by row, very clean. And then he pushes to SQL now sync. But we cannot just be uploading one row to SQL just like that, even though we are streaming it, because bulk SQL doesn't have that. It can actually, it has that capacity for you to just be uploading it row by row and it will be going. But that will be like underutilizing its power, because depending on your server resources or your system resources, that bulk copy can actually insert 1 million rows at the same time. But in order to achieve consistency, knowing fully well that we are in Nigeria, and then again we have network problem, so you have to design in such a way that in case there is a failure, you be able to catch it and then know where you stop so it can resume. So I did that also using the poly package in C# as well. So that helped me to create like a resilience chamber, a resilience defensive chamber, whereby if there's any SQL exception, it catches it immediately and then retries. Are you seeing the model now? So it's quite simple. Now, when I move this data to bulk SQL, it now uploads it, but I don't do it immediately. I batch it. I have to batch it in the. I made the batching actually dynamic, so I can choose. If I have a strong network, I can choose to batch in 100,000. If I have if I have a strong network, I can choose to batch in 300,000. If I have a poor network, I can choose to batch in 100,000. But whichever way it still works. So that way I can track each checkpoint. That is also the benefit of patching. So I can track checkpoints. So I'm uploading 300,000 per insert. Now this upload, the bulk copy is very fast and reliable, it's strong to handle, like I said, up to 1 million record. But where the my problem was actually was those memory intensive tasks I was doing, which the CSV helper actually helped me reduce and cut them off. So that actually like triple X the speed. So that was what I did. So I think that explains it. If you have any question, you can as well ask me. I'll still go further and explain. So, but like I said, this is just what I do. And this actually helps you when you have like if you are building a system where you need to sync data, like a lot of bulk of transaction data into, imagine a supermarket that runs offline. They have a software that runs their sales point of sales offline, and you want at the end of the business day you want to sync data, so that you if you build this injection pipeline this way, it will help uh, those people. They don't have to wait forever to just for their data to be uploaded to the internet, to sync to the remote server, you understand. So at the click of a button, within a minute, it says for that day is synced to the server, so you are good to go. It's a really good, and it's resilient, because even if there is a network inconsistency, you are running over a VPN like me, or your network is not that stable, the retry policy kind of helps it to retain the process for a while before final failure. Do you understand? So that helps you to to be more defensive in your programming. You get, so that is it. And like I said, this is not really that hard. But what made it look as if it's that complex, because of the frustration I went through. I first of all tried this in C sharp, and then sorry, in PHP, and it was quite slow. And this process can also be replicated in any programming language, trust me. But if you compare the speed, trust me, C sharp will always be faster. You know why? SQL bulk copy is native to SQL. It's a native to SQL server. Believe it or leave it. I've tried it before. So you can still try it with PHP. It might work, but you can't compare the speed both with PHP, Python, and C sharp. And mind you, when I did that with PHP, I wasn't implementing this thing I'm doing now, this streaming part, and the process, all the things that Csvhelper helps me to do. I can achieve that in PHP, I can achieve that in Python, but I didn't do that. It was in C sharp that I realized, okay, there's a better way, and it worked. But like I said, even if you implement it on the PHP, Python, it will still be fast. But trust me, you can't compare the speed to that of the C sharp program. So anyway, my name is Victor Annie. You can always follow me. You can always ask me more questions. Thank you.